In this question, we're asked to complete the following table, which gives us Kas, pKas, and then asks us for the relative strength. So it's probably easier to find these all as pKas and then determine the relative strength. pKas tend to be easier to look at than Kas, and basically the one with the smallest pKa is the strongest acid, the one with the largest pKa is the weakest acid. So P, if you recall from pH, is the negative log. So we're just going to take the negative log of the Ka to find the pKa. So the pKa equals the negative log of the Ka, which in this case is the negative log of 5.20 times 10 to the minus 6, which is 3 sig figs, which equals 5 point, which is not a sig fig, remember it's a placeholder when you take the log, 284. So those are your 3 sig figs. So this one, the pK is 5.284. In this question, we're given the pKa and we're asked for the Ka. So if we reverse this equation, which is done on another playlist with the pH, what we find is that the Ka equals 10 to the negative pKa, which in this case equals 10 to the negative 2.91, which equals, this is 2 sig figs, remember this 2 is not a significant figure, so it's just the 0.91 that are 2 sig figs. So therefore, it's going to be 2 sig figs, which is 1.2 times 10 to the minus 3 molar. So we're going to put that in here. Well, I'm going to leave out the molar because it's Ka. I'm just going to put it in as 1.2 times 10 to the minus 3. Finally, we need to find the pK of the last one. So pKa equals negative log of 1 times 10 to the minus 5. Since this is a 1, you don't actually have to use the calculator. It's just going to be the 5. And you have to put a 5.0 because this is 1 sig fig, and that's your first sig fig. So this is 5.0. Now we need to find the relative strength. It's easier to find the pKa first and then the relative strength. The one with the lowest pKa is the most acidic because it's going to have the most H3O+. Remember that in the Ka expression, H3O+ is on the top. So when you look at the pKa, the smaller the number, the more H3O+ is present because this concentration will be larger. So therefore, this is 1, this is 2, and this is 3. So we simply rank them in terms of their pKa from smallest to highest.